And Module 14 deals with groundwater production. I was about to say, okay, Kevin, where's my little point? Clicking. All right, so we're going to talk about groundwater treatment in essence in this module. We'll describe how it's made usable. So we're getting away from the regulatory type of training, and we're actually going to what are our groundwater sources. And so we'll be talking about the shallow wells, the deep wells, the springs that so many people, talk about, and how wonderful the water tastes. We'll talk about the required treatment for groundwater, and again, this may not be applicable to you all, and so we'll try, if you all will, let me know what you all do as far as treatment. What mainly dictate treatment will be the quality of the water. So we'll talk about common method of groundwater treatment. Now, well water may be clear, and I have seen some that looks better than that bottled water there coming directly out of the ground. And it's so cool, it looks so good, but is it safe to drink? We don't know. Why? Because it has not been tested. And there may be some microorganisms as well as chemicals that are not detected by the naked eye that can cause us harm. And so because of that, there are laws in place to make sure that it is tested, disinfected prior to distributing to public water systems. So there may be contaminants that may endanger the water. Sources of groundwater. Forgot to turn that other light off today. We have water table aquifers, which are your shallow wells. You may have, again, groundwater that is overlaid by shale or an impervious layers. That's also considered groundwater. Notice also on this one here, as far as saline groundwater, were you aware that in some cases your groundwater could be salty? Yeah, why? Because of the intrusion of the surface water. We often talk about the influence of the surface water on the groundwater source. And then the third type of groundwater or source would be our springs, which again, all a spring is groundwater that reaches the top. There are a lot of different major aquifers. What are aquifers? Aquifers are simply underground water-bearing formations that yield useful quantities of water. And as you can see, aquifers are all over the United States. Now, these aquifers will occur at different depths, different sizes, but the bottom line is you're looking at these water sources to yield useful quantities of water for public supply. Now, surface water we've already have discovered will contain lots of contaminants, microorganisms, organic material, because any and everything is put into surface water. Groundwater, on the other hand, is well filtered through the ground, but it does contain more gases, dissolved minerals, because water is a universal solvent, should contain fewer microorganisms than your surface water source. So, springs. What are springs?
Groundwater that comes to the surface.
Very good. And I know you all have probably heard about the hot springs where people like to go and hang out and things like that. All it is just groundwater. And in some cases, especially Colorado, they talk about the mineral content there. Where does the mineral content come from? From, again, all of these minerals dissolving into the water. We have water table wells, which are your shallow wells, usually 50, 100 feet. Usually you don't see the shallow wells deeper than that. And so they are not confined from above with anything. So this would be like a water table where all you have maybe would be sand, gravel above it. We have artesian wells, which are confined aquifers or overlaid by an impervious layer. Usually they are under pressure, so when you tap down into that, that water will rise all the way up to the top also because it's under pressure. All right, the thickness is simply the vertical distance in feet from the top to the bottom of the formation, and the aquifer yield, how much you're going to get from that aquifer, is dependent on porosity, permeability, as well as the thickness. That was one of y'all test questions for your state? Okay. All right, the cone of depression is simply that dewatered area in your well area. You have the radius of influence or the circle of influence there. And you want to make sure if you have two wells close together that their circle of influence do not overlap, because if they overlap, then that's going to reduce your pumping capability there. Static level we'll talk about a little later, but I'll go ahead and talk about it now. Static level is that level with the pumps not running. Your pumping level, once you turn the pumps on, what happens to this level here is that it drops down. So with your pumping level, pumps are working. The difference between the two is the drawdown. Difference between the two is the drawdown. So we say that we so you notice, you remember, but it's the drawdown. Play on words. They will do that to you, at least they do in Texas. Now, we pull so much water out because of the requirement or the need for all the water that we use with everything that we do. How are aquifers replenished? And are they replenished as fast as we're drawing out? Not by a long shot, huh? So how are they replenished? There's the natural, absolutely, there's a natural recharge such as rainfall. How much rain do we actually get? Or melting snow if you live in areas, I guess, that's snowing like it is today. But again, it's not nearly enough to re-put in what we've taken out, right? So we have recharge by percolation, rain, snow, seepage from lakes and rivers, but again, because we're pulling so much out, it's almost like mining. Subsidence is happening where, again, we are sinking. In some parts of the country, they actually take their treated wastewater and do a tertiary treatment on it and pump it back down in the aquifer. El Paso is one. El Paso, Texas. They take their treated waste. Why not? Flush today, table tomorrow anyway.
That's why you got chlorination.
You can't see what's going out.
If you're on surface water, what do you think you're drinking?
Wastewater treatment plant discharge.
Exactly. In Houston, we often say Dallas wastewater is our drinking water. Now, yes, it does take time for it to flow downhill, but that's the reason wastewater treatment is so critical, okay? Because it is, and it's not so far-fetched.
I just don't like the idea of putting water into an aquifer. So it's an unnatural process.
It is an unnatural, and those are protected areas like we talked about earlier as far as our well protection. In those areas that we are injecting it, it's well protected. You don't go all the way down into the aquifer, so you still have some, so many feet of filtration. But you're able to really kind of inject and replenish that aquifer quite well. So we do have those areas in Texas that we're using the treated wastewater. Tertiary treated, put it back in.
Do you guys have aquifer storage and recovery wells there?
Aquifer storage, no, we don't.
Yeah, 'cause we got a couple here. They'll pump it
Yeah.
into the aquifer and they'll pull it back when they need it.
Okay, okay, we don't have that.
It's a dendritic allocation state.
Yeah.
And they pump it in the winter
and then they're able to.
Bank some credits and pull it back.
Got you. Yeah. You were about to say something, Keith?
Drinking wastewater is not appalling to me. I mean, the astronauts do it on the space station. I mean, and it's the technology that's well used in some parts of the world.
Right.
I just don't like the idea of putting it into the ground again.
Right, right. And keep in mind, before you can do that, as with everything, there are permits, there are limits in place to help to ensure the integrity and the quality of what you're putting back in there. Yeah. Huh?
The ground will clean it again.
Say it again for me, Linda.
When you treat it,
Uh-huh.
and then you put it into the ground, as it filters down through the ground, it cleans itself again, doesn't it?
Right, you're getting some type of filtration also prior to hitting the aquifer itself. You're
In
absolutely
Delaware,
right.
they've determined through some scientific studies that when they put nitrates on the fields, farmers' fields, it takes 30 to 40 years to get into the shallow aquifer 30 feet down. That's how long it takes to get 30, 40 feet down. It takes about 10 years per 10 feet.
Okay,
They've done studies where they look at the different isotopes of the particular
right.
nitrates that were used and when these appear, where they appear in groundwater. It takes a long
Takes a
time.
long, even with the sandy, she said you all have lots of sand.
Yeah. And the
Wow,
study
that's
was done in
interesting.
Delaware.
Yeah.
There's a lot of clay layers underneath the sand, so.
Okay, okay, kind of help impede that movement down. So we have to do something because, again, we're sinking so much, and for a lot of states, their alternative is to go to mainly surface water source. And that's one of the alternatives in Texas that we've done. We have to be on at least 80% surface water.
Now, is that what's causing the sinkholes?
Different things may be attributed to the sinkholes. In Texas, we have a lot of salt domes, mines, and so that within itself is one of the things. I know in the area in which I used to teach, a whole street caved in, and it was because of the deteriorated pipe. There was a pipe that was running under there, if you can imagine, 107 feet in diameter. You can almost get a truck through there. Well, you can, that's how big. And because of the salt mines that were in the area also, it helped to deteriorate the pipe, and so that created a sinkhole. Not so much a natural one, but that pipe caving in did that. But there are some cases where, yes, that could be a major issue with your sinkholes.
Especially if you're in Florida.
Huh?
In Florida,
In Florida?
limestone.
Yeah, we have a lot of limestone.
With the water mains.
Mm-hmm.
Yeah.
You just be in your bed, next thing you know, you're getting ready to die.
Yeah, that was sad. All right, we're going to talk about wells, their construction, the types. In the old days, yeah, digging a well by shovel was probably something that we saw quite a lot. We don't see that anymore. And of course, these were very small wells too. They can also be bored with auger, driven with a dry point, or drill. And the drilled well, rotary drill, is the most common today that we see. Parts of a well, we have the casing, can be new carbon steel, stainless steel, or PVC. You want to make sure, my batteries must be going wrong, that if you're using plastic, that it adheres to AWWA specification, American Water Works. Do you all also use their standards for a lot of things? Okay, cool. The casing should extend at least 18 inches above the natural elevation, and it's going to also extend down into the water-bearing formation, top of that. On the exam earlier, we talked about the screen. So we have our casing and we have our cement to protect the well and help keep it from collapsing. So that's the cement portion.
Where's the cement?
This yellow part here,
Oh, okay.
that's the cement.
That's not that's the grout?
Yes, you all may call it grout.
We could even have natural backfill down there
Yeah, we don't
and
have
gravel.
any.
Yeah, the grad's just at the top,
Really?
or down to the confinement layer.
Dig-
If you
Okay.
go to the confinement layers, then you have to have more
Yeah, you don't, okay.
Pressure.
That's interesting, okay.
It works.
Yeah, if it works, that's all that matters. We have the screen itself. Now, on the screen, the purpose of the screen is to reduce the amount of sand being pumped, and then you have the gravel pack outside that screen. Also, purpose again is for the reduction of
That
sand.
screen is wider than the pipe
pumping.
going up.
Is the screen, I don't know if you can,
There's a screen, is that
No.
screen, it looks like it's all the dark
it's
stuff.
not, it's the darker,
Is the gravel pack.
Yeah.
The screen's a shiny thing in the middle, kind of.
Oh, okay,
that's
I see it
wrapped
now,
around the
yeah.
pipe, so
I see
you
it
can't
better on
hardly
that
see
picture.
it.
That's
Yeah.
the same diameter, and sometimes if one screen goes bad, they'll drop a smaller one in or something like
I
that.
thought
As
it was
a
just
repair.
part of the plastic they put in the ground, they just cut slats in.
Well, they could do, you could have the slotted ones. There are a lot of different ones that are out there on the market that can be used.
'Cause once
Absolutely.
That gets wore out,
They don't-
you're just done, right?
They don't,
Yeah.
the manufacturer does
Right,
it. AWA standard.
It's pre-prepared,
Right.
you buy it that way.
But some of the well builders will do their,
Yeah.
sometimes, which is not.
but it needs to make sure that it adhere to the specification of AWWA
Once it's in the
valve.
ground, they probably get away with it type thing.
Yeah,
Yeah, it's hard to inspect after it's in there. Buried in there.
that's true. But when I start having a lot of incrustation and problems with my pumping, then I'm gonna start doing that investigation as to why. Or if I start getting a lot of sand and other stuff up there, that's an issue.
There's no way to stop sand once it starts, right? Without having to redo the whole.
Yeah, we're gonna go in, we're gonna make sure that everything is intact, the gravel pack, the screen and all of that. Other than, because if not, then our ground storage tank, we're gonna be cleaning it out more frequently because of the buildup of that material. All right, so the screen purpose is to prevent the sand pumping, support the aquifer materials. You want to make sure that it is the non-clogging type, if there's such a thing, because you'll probably get some type of incrustation. It should be corrosion resistance. And again, the slot size is very important. We're going to base the slot size on the size of the material in the aquifer.
Is there a certain percentage of the depth that has to be the screen, or is it always just 10 feet or 20 feet, or?
Now, 10 feet, 20 feet, it just depends on your aquifer. I don't know if those are your standards here as far as your screen.
Well, like you say, it is up to the depth
Yeah.
of the aquifer, the water formation, but I think they buy it like in 10 or 20-foot lengths, so that's what you see it as most of the time.
Okay.
So they will set it
But-
with that section of height to get the most out of what they bought and set it in at a level to get the best use out of it.
Okay.
Because we have
that's-
some put in 2 screens,
Okay.
connect 2 aquifers for irrigation wells.
Mm.
They're going out.
Well, that's good.
Huh?
So there could be a cross connection in the ground. Two aquifers and you screen from both at the same time?
Yeah, they made them pull, well, I haven't read the whole thing, it's not that, but from the drillers say it's a fairly common practice if you don't get enough water in your first aquifer, just to keep going to the next one, screen the both up, but regulating agency doesn't like that.
Didn't like it at all. All right, so our gravel pack surrounds the well screen, again, to help reduce sand pumping. And it allows larger screen openings if your gravel pack is intact also, reducing that water velocity. And then we have the well vent, which acts as a vacuum breaker that allows the casing to breathe.
Then when they put that well in, how do they get all that stuff down at the bottom? They put it through the pipe that they're gonna be using, the 4-inch pipe, is that how they get the?
Once you put it in, you have to ream out also in order to put your gravel pack and all that in. So
So if they go
when
down
you
200 foot, how do you, I mean, do you put pipe down 200 foot and then put your stuff down it, or do you just put it down inside the dirt and hope it goes all the way down, or?
No, the part of it, and we'll go over that because I'll pull up another slide that actually can show you the process of how they dig the hole and then ream it out. I didn't include it in here, but I do have it, so I'll run it for you, okay? And that should help answer those questions. Now, as far as sanitation for wells, you want to make sure if you have a well that is no longer in use, that you are sealing all abandoned wells. And again, you can look in the rules and regs to see what the requirements are for that. Your wells should be protected with fences or locked houses. And when you look at what the rule says as far as your fences, if you're going to go that route, it gives very specific specification for your fences. They must be a minimum of how high? You don't have any here. Okay. 6 feet, 3 strings of barbed wire, or 8 feet tall. Yeah. Also, and you don't have this here too, all of our wells, we have the concrete sealing block. We have a meter, vent, and a sampling faucet. That's a requirement. That concrete sealing block must extend at least 3 feet in all directions. Yeah, well,
Yeah.
steel doesn't,
Now this is, where's this at? Is this above ground? Or
yes,
below
it is above ground.
ground? That's what we don't.
Yeah,
Well, some happen.
yeah, okay. And then we're, of course, we'll be testing for bacteriological quality. Before you can put that well into service, you got to have at least 3 days of back teas, and they have to come back with no coliform found.
Right.
Yeah?
That's great. I like that idea.
You all don't do that?
3 days?
3 successive days. Oh, come on. You really don't?
No.
I'm
Oh.
I wish we did because
Mm.
I think, yeah, one is not enough. It's because you can get a good one right after the chlorine goes out. And
Right.
over time, the bacteria could grow back, and then we don't realize it. And then the driller says, "Oh, it's not my fault. You got a good test."
Oh, no, you got to pull back teas for 3
3
days.
days. I like that. But all of our people are in such a hurry.
Is that an EPA rule?
Well, a lot of our rules, again, are adopted from the EPA, but the states can be more stringent. I'm not sure if this is one that we are more stringent.
No,
Huh?
well, there's nothing written
Yeah.
about well approval. It says, I mean, we need to approve it, but it's not written how, what is required to approve it.
Right, but they always refer you back to AWWA recommendations.
Is it in AWWA?
There is disinfection properties and, right, for AWWA.
Approved that it's disinfected? I mean, it tells you how to disinfect it, but it doesn't say
Yeah.
How,
Yeah, it tells you,
Yeah.
it tells you how many samples you're supposed to take.
yeah, I thought so.
how. Okay. Is it
For
two?
mains
So
and
that's,
everything, yeah.
right, it's,
Do you let it set? And then, well, I know for mains
I'm
it
not
says
sure.
set.
We don't,
well,
we don't control the wells.
with wells, it's a minimum of 6 hours after and depending on the dosage that you're putting in. You allow it to, allow that to set for 6 hours, but it's depending on what type of disinfection you're doing.
Maryland requires 2 days, but what
Okay.
they do is they let the well run for like 20 straight hours, and then they pull a sample to get 100 milliliter. So of course it's gonna come up good.
Right.
You know, it's like when you shut down and put it in normal operating conditions, then can you get a good sample. I mean, but all that running that they do, that probably does help improve the water quality.
It probably does. And keep in mind, what we're trying to do is to ensure what we've put in, that the well is properly disinfected by allowing it to run for that long, because we do that with our chemical and physical analysis, is that now I want to know what's representative of the water that's in the aquifer. And so maybe that's the stance that they're taking also. They're checking the water in the aquifer as opposed to the well itself in the process. I'm not sure. Yeah. But I know on our chemical and physical, it's after 36 hours of continuous pumping. Okay. And then you want to make sure that you secure sanitary control easement. And you all told me that you all did say you have something where there's no source of contamination within 150 feet, or sanitary, huh?
Next to a sewer system.
Oh, the sewer. Oh, okay. With the sanitary control easement, we make sure that we have, again, access within 150 feet, especially if it's crossing over other people's property. We make sure all of this is logged in at the county courthouse.
We have this.
Yeah, same there. Cool.
But 50 was already in request.
Yeah, I hadn't gotten to that yet. Yes, absolutely. So that's pretty much what our installation looks like there. Huh? What was that, Rebecca? 500? All right, now as far as sanitation goes, safe distance from a well, there should be no source of contamination within this little red spot here. 50 feet, absolutely nothing.
Is that a rule?
Nothing.
Is that a lockdown rule?
That's our lockdown rule. That's our lockdown. But again, each state can choose to be more stringent. So
You can have force mains, things like that, within 50 feet if they're double encased and.
there are exceptions to the rules.
Okay, that's-
Yeah. But 50 feet, no source of contamination. Livestock, your storm sewers can be 51 up to 150 feet, and of course further out if you want. But that's where you can start putting them in. Your underground fuel storage tank, we're looking at 300 feet. Wet wells, wastewater wet wells, pumping station 500 feet. Absolutely no animal feed lots, wastewater treatment plants, solid waste disposal sites, or irrigation with wastewater effluent. I don't know if you all do that here, but absolutely not within 500 feet of that public well.
No spray irrigation?
Not within 500 feet of that public well. Okay. And we do have lots of irrigation in Texas with wastewater effluent. And so again, the bottom line.
So what do you grow?
Huh?
What do you grow?
Oh, they grow everything, all kinds of crop there. Edible.
Edible?
Yeah.
The same things that Delaware grows.
I figured we grow it for animal feed.
We do a lot of that too. Yeah.
You're not allowed to grow it for people.
All right. So after construction, the well must be developed.
Here once for 8 years ago.
The well must be developed, and what do we mean by developing a well? As we are drilling, all that stuff that we're putting down there, we want to make sure that we're taking it out. And of course, doing the drilling process, you want to make sure you're using chlorinated water. But it's developed to remove the sand, to rearrange the gravel around the screen, and remove the drilling mud that's put in place. So how do we develop the well? You can overpump it by 15-25%, backwash it, in other words, reverse the flow. You can surge it with water, use compressed air to agitate it, as well as jet it, using high velocity to remove the drilling mud from the formation wall. And then you want to make sure you go the next step and do the testing. We're testing for efficiency, capacity of the well, and pump efficiency. What's the recharge potential, the recovery? What do you expect? How many gallons per minute? All of that. Aquifer characteristics. Remember the chemical, the physical characteristics of that, because that's something that will be ongoing every 3 years. Then you want to make sure that you're disinfecting it prior to use. One method, and I do stress one method because there are several. One method is the use of 50 milligram per liter dosage chlorine. Allow it to stand for more than 6 hours. Take your back T samples, and remember we're testing for 3 successive days, and they must come back negative before you can put it into service.
I thought they were supposed to do 200 milligrams per liter.
Again, there are different methods, disinfection, and you choose which one works best for you.
At the time, if you had a higher concentration.
Absolutely,
Well, sometimes
absolutely.
You have to go back 5 and 6 times before it works.
You have difficulty with new
Really?
wells.
A lot of that room-
At 200 milligrams per liter?
You got high pH, it's hard to disinfect. Wow.
Yeah, and that's interesting because disinfection is dependent on pH. And if your pH is high and you're adding something that is acidic that works best at a pH of 4, then you're going to have to use higher dosage, absolutely. Well, he just said your pH were high.
He's a surface water
Shallow
person.
and unconfined aquifers, and confined aquifers
Or high pH. Okay, got you. Yeah. So looking at the chemistry, the characteristics, quality of the water will affect your
So
disinfection.
we have a deep well, then we have a high pH, and we have issues with the chlorine. So if we do a shallow well, it's really good.
Normally we let it sit for 24 hours.
24 hours, and that is one method. Do you all do 100 milligrams per liter for 24 hours, or
That's what, I think their recommendation is to dose it at 200. So
200?
You should have 100 left after.
Okay,
20
residual.
minutes.
got you?
Was the reasoning for our engineer came up with those numbers years ago.
Yeah, and there's something in, like, natural resources and environmental control permit the well drillers and the wells. And then we give them approval for use, so it's in the well drilling regs, how to disinfect a well. But then we're the ones that, if anybody makes them prove that it worked.
Right.
We do, you know, so that's a little disconnect, like, between the agencies.
Mhm.
Like, they do say on their well permit, you have to get approval from public health before you use it.
Okay.
Well drilling regs say they must disinfect. It does not say they must confirm that the well has been disinfected.
Right, just disinfect, but there's no
We
confirmation.
commented on that every time they revised the regs, and they still never got their requirement to test it, to confirm it's been disinfected. But
So then, do you make the systems disinfect or prove that?
Well, we will get there shortly after it's been.
Because you all
turned
do.
on. Sample it. If it's bad, usually the well driller will come back and disinfect at no additional cost. If you
Okay.
get there soon enough. If you wait a few weeks or a month, then he's gonna say, no, you contaminated and charge you.
Right, hey, we're out of there by that time, so it's on you. So let me ask you this, then does the state of Delaware take on the responsibility for the disinfection? No.
Water system.
It's the water system,
We
okay.
just hound them.
All right, got you. Then physical chemical analysis after 36 hours. Again, static level is that water level when the pumps are off. That is your normal level in that well. Your pumping level is a level when the pumps are on. And the drawdown is the difference between the two. So drawdown, not drop down, right?
Yeah, I caught that.
Drop down's military.
All right.
Drop down, so I know that's wrong.
One of the most common pumps that we use in the water industry is the,
Yes, dude, where's the failing? No way.
I've lost control. We had the ladies singing yesterday. Now the guys want to stop, drop, and roll. Is there a little dance to go with that too?
Show us how it's done.
Oh. All right, one of the most common pumps we use in our industry is a centrifugal pump. There are several types of centrifugal pump. Very ease in operation of centrifugal pumps. Works with centrifugal force. Water enters in through the eye and it's spun out with centrifugal force to the discharge. Of the centrifugal pumps that we use for wells, one would be the submersible. Okay. We also have the vertical turbine, and usually if it's a well pump, it'll be set up in series where again you have several impellers working in tandem to get that water up. So for treatment, now here's the hot topic. What type of treatment is required for groundwater? And the correct answer will be, it depends on the quality of the water. Okay, so we all can agree on that. I won't say you must disinfect. It depends on the quality of your water. So some of the common treatment techniques then, now that we've established that, would be aeration. If you have gases and things like that, excellent. Corrosion control. If you have corrosive water softening, there may be special processes such as coagulation and sedimentation, reverse osmosis. So let's look at individually what each one of them will take care of. Aeration can remove objectionable gases, iron and manganese, if you have a problem like that, especially oxidized iron in the water causing corrosivity. Aeration will scour the waste gases such as hydrogen sulfide. You mentioned earlier, some areas you have that problem there. Carbon dioxide as well as methane. In addition to removal of all those gases, it can also improve the taste. So aeration could be possible based on, again, the quality of your water. Changes soluble compounds into insoluble compounds. Corrosion control. Now, we all would love to have stable water. Stable water is that water, again, that is not corrosive nor scale forming. And usually stable water is near neutral pH. So, what happens if I just don't have the luxury of having that as I pull it up out of the ground? What can I do if I have corrosive water?
Caustic soda.
Caustic soda. So in other words, what you're saying, if I raise the pH up, I won't have the corrosivity that may be occurring. Okay, cool. One alternative. Very good. What else? If my corrosion is happening because of different metals that may be present, okay, I need to make sure that I am getting rid of the two metals that's causing the corrosivity there. Low pH is one of the reasons why. Caustic soda. Dissolved gases, I can dissipate those. High temperature, high mineral levels. So all of those are reason why.
Are you talking about the iron?
Iron, copper, and all of that stuff in there, yeah, can create corrosive water. Corrosive water will deteriorate metal surface that it contacts. Again, aeration and pH adjustment, awesome methods in order to help with the corrosion problem. Sometimes I may have to go above and do something else, depending on what's causing the corrosivity. If it's an iron problem with some other metal that may be there,
What's the NaOH?
sodium hydroxide,
Okay, yeah.
which is a base. Yeah, I know he was testing the instructor.
I knew I'd seen it somewhere, but I couldn't remember what it was.
No, you just tell her you were testing the instructor.
Back in the wastewater days. I want to try to get it right.
There you go.
Hey, I'm always trying.
Do you have hard water? Oh, you do. Now, do the systems take on the responsibility of removing the calcium and magnesium?
No, I
No.
hear, compared to the rest of the country, we don't have hard water, but our people here think we have hard water.
What are we talking about? Over 300?
Scaling on the spigots.
Yeah,
Yeah.
yeah.
Well, I think just that's what you, huh?
Calcium, hardness.
Yeah,
Yeah,
250 to 300. Okay, we have some that high. Anything over 100 is considered now you're getting hard, but there are some areas of the country where you're looking at 600. That's real hard.
Soap won't
Yeah.
lather up at all.
Huh?
Soap won't lather up at all.
Yeah, major issues there. It can, hardness is caused mostly by calcium and magnesium. Also iron and manganese may contribute to it also. So it can be softened by lime addition, calcium oxide, ion exchange, reverse osmosis, soda ash. Now, in Texas, we leave that up to the consumer if that's an issue with them, whereas they can install things in order to soften their water because it's just so expensive to do it at a system level.
Yeah, I think the only thing we really require is like if you have a fluoride saturator, they have to remove it to under 70.
Okay.
Like that, you know,
What was that, Anita?
Before the fluoride.
Before?
So the
Is that
fluoride
just
is
for
involved.
fluoride, water?
Yeah.
The only thing we would do if they have high iron or manganese and they need to meet the qualifications would roll, mainly that didn't do both.
Lord.
We enforce
Okay.
secondary standards on greater than
So they must adhere to the secondary.
So the little people have to suffer.
That's my area.
Yeah.
My area's got little people.
But it's
Uh,
an economic thing.
And, huh? He's the champion of the environment. We're going to get him the little badge. So from now on, he knows that. Wow.
I got the
Well,
bag.
he's a surface water guy anyway.
All right.
We're going to
Well,
Burger King, one of those crown.
yeah.
You know?
Now again, there's some other.
I think you got that just.
There are some other options that are out there depending on, again, the quality of your water. You have a problem with arsenic, fluoride, lead, mercury, nitrate, and silver. I did not put the treatment option because now this is your opportunity to tell me what you remember from yesterday, because we talked about several treatment options for all of these with the exception of silver and mercury. I think they were the only two that we didn't mention yesterday. And Rebecca has a reprieve because she wasn't here. For the rest of you, when we talked about the treatment option,
She's up training up north on Tuesday, so she's not over.
for arsenic,
Versus osmosis.
okay, that was one, absolutely, super. Huh? Yes, it did for all of those. Matter of fact, if you want to just use the blanket approach, we can say RO for most of them, for all of them. Okay. Now, it's interesting because we do look at ion exchangers, demineralizers, reverse osmosis as being very, very effective, but also simple coagulation, sedimentation, and filtration can work for most of them too. Most of your inorganics can be removed by that. So you're not using the costly thing. Very good. All right, they mention again surface water influence on groundwater. Remember, groundwater under the direct influence of surface water. Now I can no longer say I'm not going to do any type of treatment whatsoever, or I'm just going to chlorinate if I start seeing all of these surface water organisms coming up and there's a fluctuation in my quality or parameters that I'm looking at, such as pH, alkalinity, and all of that. Then I need to start doing additional testing. So I'm going to look and see what impact on the shallow wells my surface water is having. So I'm going to target those at-risk wells. I'm going to refer back to my surface water treatment rules. Identify the risks of Giardia, Cryptosporidium, and the other organisms of concern. Evaluate that surface water influence, and then from that, I may be required to actually start implementing some of the required surface water treatment. Okay. Is there any questions, comments, concerns, or issues? That's a crab. Now, how do you all not know a crab and you're in Delaware?
Crap with a local rail top of his head.
That's It's Photoshop. It's Photoshop. Are there any questions, comments, concerns, or issues?
We'll bring happy pad fees.
Concerning groundwater production and treatment. So again, pulling the water out of the ground is not so far-fetched, not so difficult, but once we get it out of the ground, we need to know the quality of it, whereas we can respond and test it appropriately. All right, no questions? I'm gonna pull up this other little bit. Oh, someone hit me here.